Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge, let's get it up here, is combination sum. All right. A lot of these there's a lot of these must-know interview questions under the category of backtracking. What topics do we have here today? Yeah, backtracking. Okay. It's a medium rated challenge. Let's read it. Given an array of distinct integers, candidates, called candidates. Well, let's look at the method signature. So what is the input here? We've got a method called combination sum. One of the inputs is an integer array of candidates. One of the inputs is an integer called target. All right, so you can probably anticipate what the challenge is going to be. So we need to return a list of all unique combinations of candidates where the chosen numbers sum to target. Combinations can be returned in any order. The same number can be chosen from candidates an unlimited number of times. We'll look at an example of that. Two combinations are unique if the frequency, whoa, hold on a second. The number of times it occurs in the array. If the frequency of at least one of the chosen numbers is different. Okay. The test cases are generated such that the number of unique combinations that sum up to target is less than 150 combinations for the given input. Wow, that's a lot. All right, so okay, a couple examples. So let's say we have a candidate array, 2, 3, 6, 7, and a target of 7. We can do that a couple of ways. 2, 2, 3, that sums to 7, and 7 sums to 7. Okay, let's look at the next one. 2, 3, 5. We want to sum it to 8. So one possibility is 2, 2, 2, 2. One possibility is 2, 3, 3. One possibility is 3, 5. This is a lot like, well, it's a depth first search. It's a backtracking algorithm, and so it looks like a lot of the other depth first search backtracking algorithms that we've done, including combinations. Let me grab the solution to combinations here. It's not exactly the same, of course, but it's similar enough that we can probably at least save some typing. All right, so let's grab that, and let's go over here to combination sum, okay? And paste this here. All right, so one thing we need to change is the method signature is going to be this. Let me scoot this over. All right. Now, what do we need? What do we need as far as class variables? So we do need something like called combinations or combos. That is going to be our list of combination lists. We need that. The current combination that we're building up. We need that. N and K, we don't need that. That is from combinations when we were given numbers from 1 to n, and we needed to select combinations of size k. That doesn't apply here. What applies here is we have an array of numbers that come in. They're called candidates, and I suppose we could call it candidates up here as well. Private int, it's an integer array of candidates. Yeah, let's go with that. All right. So then we go into the combination sum. We're going to have a depth first search method. Again, we don't need n and k. What we need well, we don't need to do this, but it might be a good idea. Actually, let's first put the, what is it called? Yeah, candidates. This candidates equals candidates. All right, so we don't need to pass those around. That's a class variable. We can sort the candidates. We don't have to sort the candidates. It's just, it's going to be a little more efficient to sort the candidates because, as we do a depth first search through the candidates array, then if we find a candidate that makes the sum greater than the target, then we can just prune the depth first search right there, because every candidate number after that is going to be larger than the candidate number that we're looking at. So it's just going to get, even further past the target. So this helps us prune candidates because we know when we're past the target, there's no sense in continuing the search. All right, DFS. What are we going to pass to DFS? We are going to pass the start index into the candidates array, and we're going to pass the target. We're going to pass the target. Now, you might say, couldn't you just have the target as a class variable? And the answer is no, because we're using this as, so let's see, what do I want to call that? I mean, I is probably okay. I don't know. Let's call it index. And the other thing that comes in here, it's not the target. It's actually the remaining sum. Okay, this is how we know when to stop. All right, so when we have a combination that sums to remaining sum, or it's greater than remaining sum, then we know it's time to stop. If it equals remaining sum, then we've got a valid combination. We can put that into the output list. All right. So we check this condition a little bit differently, and we will say this was the base case for combinations. The base case for combination sum is if the remaining sum equals 0. And if it does, then add the current combination to the output list, which we've called combos. All right? Now there's another thing here, if I equals n. So that is the index going past the, well, again, for combinations, it goes past n. For what we're doing is if the index goes past candidates.length, all right, we've gone past the length of the candidates array. So we got to stop. Now, the other thing that would cause us to stop is if the remaining sum is less than, this is going to be too long. Actually, let me scoot it over. It might be okay. If the remaining sum is less than candidates index, okay? If the number that we're looking at is going to put our sum past the target, Okay, it's not good. So we got to return for that as well. Okay. So let's see. All right, at this point, if we get here, we're working on a combination and it has not reached the sum yet. So we're going to go on, continue the depth first search on the next candidate, index plus 1, and this also again takes the remaining sum. Okay. I didn't mean to do that. All right. Let's see. Current add candidates index. All right. What happens when we continue the depth first search here is it's either going to get too high or it's going to return something successfully. All right, that's good. When it comes back from that, we can explore the possibility of using the current candidate more than once. All right, so we add the current candidate again and then continue the depth first search on the index and remaining sum minus the index. That's actually not, no, that's not how you want to do that. Candidates index. All right, that should be good. When we come back from that, to enable backtracking, we have to do, this never seems to change actually. When we come back from that, we have to take that off. Just take that off. When we come back from that, we have to remove the most recently added combination. I'm sorry, candidate, and then continue from there. So let's see. Let's kind of walk through. All right, I think this is okay. I think it has to be in a slightly different order here than the combinations, but it looks right. We're going to do depth first search. We're going to put the number in there. We're going to go to the next number. We're also going to consider here that we can use the same number more than once. So we're going to do continue doing a depth first search on the same index. So we've covered both possibilities. We've covered the depth first search moving forward to the next candidate. We've covered the depth first search continuing with the same number. All right. And I don't know. Let's try it. Compile error array sort. Oh, that should be arrays sort. Number 7, arrays sort. All right. Anything else there? No. Runtime error. X4 out of bounds. Oh boy. Where did that happen? Line 20, line 24. All right, I'm a little puzzled on that one. If index is greater than candidate's length. Oh. Sorry. If index is greater than or. I'm going to say, well, that should short circuit and you would never get to the second part of the or. It should be greater than or equal to. All right, we'll try it again. And, oh, that worked. Okay. click over here and pull this out a little bit so we can see it. Submit. And 2 milliseconds. Oh, it's good. What is the runtime on this? I mean, so for each candidate, we can either use it or skip it. So it seems like a 2 to the n, where n is the length of the candidates array. Let's take a look. Oh my God, I didn't analyze anything today. I don't think I did. Well, okay. So again, backtracking, combinations, combination sum, permutations. Those are backtracking algorithms. Depth first search. Set up a recursive algorithm to go through your input, and that's it. It's the day before Thanksgiving. I'm leaving town here in a minute. I wanted to get one more of these before Thanksgiving. Have a good Thanksgiving. I hope you enjoyed this. Feel free to like, subscribe, comment, and see you next time.